Hi everyone, welcome back to my channel. Today I'm here going to learn one of the most important topics, that is 8086 architecture. If you are B.Tech EC student, you feel 8086 is a little confusing. And don't worry, I'm explain entire architecture and step by step and circuit you make super easy with 8086. So let's get started. So before first we understand what is about architecture of 8086, you have to and first of all understand what is 8086 actually is. So 8086 is a 16-bit microprocessor, and it is a 16-bit ALU and 16-bit registers and 20 bits of data address bus. So it contains 20 bits of address bus, and it access of 1 megabyte of memory. This is a main important pointer. You remember this. 8086 architecture has contained major two parts. One is the bus interface unit and second one is execution unit. First, discuss about each one. First, in bus interface unit means it is deals with the fetching and instructions in communicate of memory, like a segment register, instruction queue, and bus control logic and address generations. These are the main instructions in bus interface unit. Next, execution unit. Execution unit means AU. AU means it is mainly deals with the decoding and executing those instructions. Okay, like this is used for general purpose register, ALU, and flag registers. And it contains, it has the control buses, signals, and address buses also. Before I told you, 20 bits of pins are there. So BLU means fetch, execute. Okay, AU means execute. Just you remember these 2 points. So now first we are discuss about each of the topic. Okay, ALU. First, we are discuss about 2 units of work which is parallel to improve performance. First of all, we discuss about bus interface unit. Bus interface unit means it is handling all operands and related to the memory and outputs and fetching the instructions. Before I told you, bus interface means only fetches the instructions from the memory and stretch them into an instruction queue. And it generates the physical address from for your memory access. And it contains the following categories like segment register. Here 4 types of segment registers are there. SC and DS and SSES. SC means code segment, data segment, and start segment, extra segment. Here 4 types of segments are there. Next, we are have to know about instruction pointer. Instruction pointer means the IP contains offset address to the next instructions, and it need to fetch it. Like I explain you. BLU contains the segment address and offset address to generate the physical address. So physical address is equal to segment into 10BH. This is a formula I told you. 10H plus offset. So now next, how it is works ALU, and next these pointer index registers IP, SP, VP. Was only 16 bits are there. Within the box, it has contained 6 bits. And next execution unit means EU. It executes the instruction and perform the arithmetic, logic, and data perform transfer operations. Arithmetic means addition, subtraction. You know that all about. And logic and OR gates are so performing. And here it contains as 3 types like generating purpose registers AX, BX, NCX, and DX. And ALU has contained again ALU unit flag register also so many types. For the video I will explain you detailedly. First of all, AX, BX means it contains registers. These registers are used to store the both operands and results. To each of them can be accessed as a whole. And like AX has again contains 2 types, AH and AL. Okay, again each one has contains two types are there, means higher and lower. Next, AX is used for arithmetic and input operands. BX is used for the basing addressing, and CX is used for loop and shift operations. DX is used, data registers are used for the arithmetic and input output operations, like data is transferring from input to output. So each register can be divided into 8-bit registers. So it has a AX has containing 8-bit register. You have to clear about that. Next. AX means I told you no before, AX has containing 2 types, AH and AL. Similarly, BX, CX, DX also containing higher arithmetic and lower register also. Okay, these are the 4 types of registers. Next, we have diagram of 8086 architecture. Before I told you, no, these are containing two types of, mainly major two types of this. One is the bus interface unit, and next one is the execution unit. But bus interface unit contains again segment registers and instruction queue and bus control logic and address generation and 20-bit address lines. Okay, these are the address lines. And next here, EU. EU contains has a general purpose registers, AX, BX, DX, CX, like that. These are the general purpose registers. And ALU. And next, flag registers. This is also 16-bit register. I briefly tell you about this registers in another video. First of all, discuss about registers of 8086. Here are four types of register there. What's that? Accumulator register and base register, counter register, and data registers. These are the. So these registers are used for 8-bit or 16-bit data operations. Here, either it perform AX means it is performed like 16-bit. AL and so whether it can work as a 16-bit and 8-bit also. Okay, next we discuss about segment register. Segment registers means it has contained four types of them: CS, DS, and SS and ES. CS means code segment, data segment, stack segment, extra segment. Code segment are used to point to the code. Okay, and points to the data segment and points to the stack segment. Each segment's registers are useful for points to the extra segments, like that. Okay. Next, pointers and instruction registers. It is also a 16-bit registers. IP, SP, BP, SIDI. IP means instruction pointer. The pointer points to the next instructions. When instructions are given to the one place to another, it is performed like instruction. Okay. Stack pointer means the point of top of the stack. And base pointer means I access the parameters to the stack. When which type of parameters are used. So base that works as a base pointer. And next, source index. Source index means it is used to string operands like sources or anything. And destination index. Destination index as a work as the same as it is used to string operations and within the destinations. Okay, these are the types and architecture of 8086. I hope this is so. This is the complete architecture of 8086 microprocessor. As we discussed, the architecture is mainly divided into two important units: BIU and AU. Means bus interface unit and execution unit. Bus interface unit means fetching the instruction and handling the communication with the memory and input and output. Here, EU means it is decoding and executing those instructions. And so we discuss about important blocks such as a segment registers and instruction queue and general purpose registers also, and the pointers, index registers, and these are the topics. So these are the easiest way to remember. Execution means fetching. Bus interface means fetching, and execution unit means execute. I hope 8086 architecture is clear to know. And this video will take each block individually and understand how it works with simple examples.